first question that we have says several points are plotted on a graph. Which of the plotted points on the graph represents the zeros of the function f of x equals x squared plus 2x minus 8 times x minus 6? Select all that apply. So first things first, we have a whole bunch of options and we are looking for the zeros of this function. So if you remember, the zeros of a function basically just means where it's passing through the x-axis. So in this case, it's a little bit easier. We can use process of elimination. The points C, F, and G are not on the x-axis, so therefore those cannot be zeros of the function. That tells us that we're only left with E, D, A, and B as our option choices. So how can we solve for the zeros of this function? The function that I have is a trinomial that's multiplied by a binomial. And essentially, wherever these two are equal to 0, that is going to be the zeros of my function. So looking at this one right here, I have the standard form of a quadratic, which can easily be factored. So if I wanted to factor this, it would turn into the product of two binomials. So looking at that, I need two numbers that would multiply to -8 and add to +2. When I do that, I can rewrite this as the product of x plus 4 and x minus 2. Because 4 times -2 is -8. 4 plus -2 is going to give me +2. And then I've got x minus 6. So now I've got the product of three different binomials. Since I'm solving for the zeros, what I'm going to do is I'm going to break up these into three different factors. And if I'm solving for the zeros, then I'm essentially just looking for the solution when each of these are equal to 0. When it's time to go ahead and solve this, it's pretty easy. It's just inverse operations. So to get x by itself, I would need to subtract 4 from both sides, which tells me that x equals -4 is a solution. Here, to undo the subtraction of 2, I would need to add 2 to both sides, which gives me +2 as another value. And here, same thing, to undo subtracting 6, I will add 6 to both sides, and that's going to give me 6 as my final solution. So now looking back over here, I've got -4, which is D, 2, which is A, 6, which is B. So A, B, and D are the correct choices. The next question that we have says, which graph best represents the solution to this system of inequalities? So we've got x plus y is less than or equal to 6, and then x plus 2y is less than or equal to 8. So I'm looking for which graph shows both of these linear inequalities that are being graphed. When I hear the word linear, my mind immediately goes to linear equations in the form of y equals mx plus b. So what I'm going to do is I'm going to rewrite both of these inequalities so that they match the form y equals mx plus b, except instead of an equal sign, we'll have an inequality symbol. But once I know the y-intercepts and the slope, it's going to be very obvious which one of these is my correct option. So first I'll go ahead and rewrite this top problem. So I am going to get this so that it matches y equals mx plus b. Right now, it's x plus y is less than or equal to 6. So in order to get it to match, all I need to do is just get rid of this x, move it to the other side. In order to do that, I can simply just subtract x from both sides, and that leaves me with y is less than or equal to -1x plus 6. Now to rewrite the next one, it's going to be a little bit more work, but not much. So I've got x plus 2y is less than or equal to 8. Again, I need to get rid of the x, move it to the other side, so I can subtract that. It's going to cancel over here, and I have 2y is less than or equal to -x plus 8. I'm almost there. I have 2y is less than or equal to mx plus b, but I just want the y by itself. So to undo the multiplication of 2, I'm going to divide everything that I have by 2. This is going to leave me with y is less than or equal to negative 1/2 x plus 4. So now, if you're familiar with slope-intercept form, these should look very familiar. Notice how in my options, both of these have negative slopes. So when I'm looking at the options that I have, both of A and B are showing positive slopes. So right off the bat, I can eliminate those. That leaves me with C and D as my two choices. So looking at my problems, my value of B for this linear inequality is 6, and for this one is 4. These represent the y-intercepts, which is where I cross through the y-axis. So looking here, 1 crosses through 6, 1 crosses through 4, but here I've got something crossing through 6 and 8. So just by process of elimination now, I know that D has to be the correct answer. The next question here says, which expression is equivalent to 3x to the 5th plus 8x to the 3rd minus 7x squared minus 6x to the 3rd? So if you notice, I'm taking this entire binomial and subtracting it from this binomial. So I need to think about this as distributed subtraction because I'm not just subtracting this one term here, I'm subtracting both of them. So the one thing that I always tell my students is to imagine that you have an invisible -1 that's out in front of this binomial. In order to solve this, we can literally use the distributive property to distribute that subtraction to both of the terms in my binomial. The problem now becomes, I can take away my parentheses, the original one stays the same, and I've got minus 7x squared. A negative times a negative is a positive, so plus 6x to the 3rd. I'm not done yet because now I need to look at the problem and figure out what terms can I combine here. So I'm looking for like terms, and remember like terms have to have the same variable raised to the same power. So in this case, I've got an x to the 3rd and an x to the 3rd. Those are the only ones there that I can combine. So if I were to go ahead and combine these, positive 8x to the 3rd plus 6x to the 3rd gives me positive 14x to the 3rd, and then I've just got my minus 7x squared hanging out at the end. There's nothing that I can do with that. Therefore, the correct option is C. The next problem that we're given says find the equation that is equivalent to the quadratic equation shown, and we're given x squared minus 6x minus 27 equals 0, and then we have 4 different options that we need to pick from. There's a few different ways that you could go about this problem, but honestly, as someone who feels confident multiplying binomials, I feel like my first instinct would probably just be to use a guess and check method in this case to see just when I expand these, which is going to give me the original question that I'm given. So I will start with A. So in this case, I have got x times x minus 3 equals 27. So in this case, it looks like a simple distributive property problem. So if I distribute here, I'm going to get x squared minus 3x equals 27. And off the bat, I know that this is not going to be the correct answer because I'm looking for a negative 6x. So the fact that I don't have that, I'm just going to eliminate choice A. All right, now let's go on to B. So I've got x minus 6 squared equals 63. So remember, to square something just means to multiply it by itself. So this is the same as saying x minus 6 times x minus 6 is equal to 36. Now, whenever you're multiplying two binomials, you should use the FOIL method, which stands for firsts, outers, inners, and lasts. So I'll go ahead and multiply the first two terms. X times x gives me x squared. The outer terms in this case, I'm going to do x times negative 6, which is negative 6x, Then I've got the inners, which is, again, negative 6x, and my lasts will give me positive 36. Now, if you take a look, I have got two like terms here that I can combine. So negative 6x minus 6x, that is going to give me negative 12x, and I can stop at this point because I know that I don't have a negative 6 as my coefficient for the term of just x. Okay, moving on to the next one. Again, I'm going to expand this and FOIL it. So x minus 3 times x minus 3, and that is set equal to 36. So I'll go ahead and I'll FOIL firsts, outers, inners, and lasts. All right, if I go ahead and combine my like terms now, negative 3x minus 3x does give me negative 6x, so far so good. Plus 9 is equal to 36. So we're close, not quite there yet. If you notice, our original problem is set equal to 0. So if I want this to match, all I need to do is get it to also be equal to 0. In order to do that, I'm just going to use inverse operations. So I will subtract 36 from both sides. Over here, it's going to give me a 0. And on this left side, 9 minus 36 is indeed negative 27. So we have found the correct option. C has to be our correct choice because when I expand, I get the exact same thing.